Hello, what's going on, guys? This lecture is all about how to identify and classify individuals and variables. So first off, let's define these keywords in a stats context. You see, an individual is the person, animal, or thing that is being described by data. And a variable is a characteristic that describes that individual. Now, that characteristic might change from individual to individual, or it might be the same. The idea is that the variable can take different values. Hence, its outcome varies. So this is slightly more nuanced than your algebra understandings. We won't focus on x's and y's too much for right now. Instead, we are going to describe variables with words that are specific to the problem or study at hand. That means we are going to talk about the variables in context, which will be a major running theme in this course. So how do we work with these variables? Well, one of the first tasks you should complete whenever examining a study in statistics is identifying the variable of interest and classifying it. While it is a relatively simple idea, it is surprising at the end of the year how many students forget to do this essential task. You see, we have two different types of variables, and the way in which we analyze a variable depends on what type of variable it is. Now, those two types of variables are called quantitative and categorical. A quantitative variable is something where the different values the variable can take are numerical, and it makes sense for us to perform arithmetic with them. Next is categorical variables. A categorical variable assigns individuals to different groups, labels, or you guessed it, categories. You see, when you get into more sophisticated science course, this is also called a qualitative variable. And you may use these terms interchangeably, and so will I through these lectures. So just be flexible. An easy example of a categorical variable might be the answer to a survey question like, hey, what's your favorite Harry Potter book? There are 7 different books in the main Harry Potter series, so there are 7 different categories that an individual might fall into. I would answer book 6, The Half-Blood Prince. You might answer book 6 too. Or maybe you'll answer book 3, The Prisoner of Azkaban, because that's when Hermione pops Malfoy a righteous one in the face. Now here I imagine you jumped out of your chair and started screaming at your screen. You just said quantitative variables are numerical. You just said that those books have numbers. Well, here's the caveat of a quantitative variable comes in. A quantitative variable is something that is numerical and you can perform arithmetic with those individual values. The easiest way to determine if a numerical variable is quantitative is to ask yourself, can you take the average? Does it make sense for me to take the average of the Harry Potter book numbers? Well, if we did that, we would get the average Harry Potter book is book 4, The Goblet of Fire. But what does it mean to be the average Harry Potter book? That's a meaningless quantity. Moreover, the number of a book is really just an assignment for the book itself, or its title, and its title is obviously not numerical. It still doesn't make sense? Well, let's think about this. You have a phone number, and I have a phone number, right? Well, they're both numerical, right? Well, is there any meaning to the average phone number, though? Of course not. So, lots of things, while you can describe them numerically, are categorical. The rule of thumb is to ask yourself when presented with a variable that you're not sure if it's quantitative or categorical, is ask yourself, does it make sense to take the average? If the answer is no, then you've got yourself a cool categorical variable. Now, what is quantitative then? Well, let's say we were curious about the length of Harry Potter books. We could look at the number of pages. Now, the average number of pages in a Harry Potter book is a quantity that has meaning. So that's definitely a quantitative variable. We could look at the amount of time taken to read a Harry Potter book, the number of words, the weight of the book. All of these things have sensible averages. That's what defines a quantitative variable. The last thing that we want to introduce is the different types of quantitative variables. See, quantitative variables can either be continuous or discrete. We won't focus on this too much for right now, but it will be important later in the course, so it's a good idea to identify the type of quantitative variable you're looking at whenever you start your analysis. So what are they? Well, a discrete value is one in which there are finite gaps between potential values, or the assigned values, right? So think about your shoe size. The average shoe size of people in a room is a sensible measurement, so that makes sense as quantitative. I wear a size 13 shoe. You might wear a size 8. Your neighbor might wear a size 8.5. But nobody has an 8.25 shoe. Or an 8.3741023997. You get the idea, right? There are clear gaps in between the possible values of a shoe size. A continuous variable, however, potentially has no gaps, or those gaps are so infinitesimally small. If you have precise enough measurement tools, maybe you could find a possible value in between any of those two. For these, think about your lab science. You got your measurements of height, weight, distance, time. You see, all of these things are generally going to be considered continuous because I can always measure time down to the nearest millisecond, nanosecond, whatever the smallest unit of measurement might be, right? Now, let's consider a data table and try to identify these as either categorical or quantitative. And then for those quantitative variables, we'll define them as either discrete or continuous. First, we ask, how many individuals are in this set of data? Well, we usually use the letter N to refer to this. Notice there are 5 different rows here and 5 different values for each variable. What does that tell us? That means that it describes a sample of 5 individuals. That means we have N equals 5. Then we see that there are 1, 2, 3, 4, 5, 6, 7 columns with actual data in them. Thus, there are 7 different variables. Now let's take a look at the first one. I can't take the average hair color, so obviously that is categorical. The same goes for zip code, phone carrier, and operating system. That leaves us with height, hourly wage, and best bowling scores being quantitative. Obviously, there are gaps between the different values in each individual's heights, but that doesn't on their own make them discrete. It's about gaps between possible values, and there could be somebody that is 65.3495742057238 inches. Thus, it's a continuous variable. For the other two, we're going to need some contextual understanding to see if they're discrete or continuous. For best bowling score, I know that I can't knock down half a pin. Nobody scores 120.5 in bowling. And the same goes for hourly wage. Somebody might make $15.25 an hour, but nobody is making half a penny an hour. So even though there's a decimal associated with those values, hourly wage is going to be considered a discrete variable. And there you have it. Let's recap what we've learned. An individual is a person, animal, or thing that is being described by data. And a variable is a characteristic that describes that individual. Variables can be either categorical, aka qualitative, or they can be quantitative. To be a quantitative variable, the average value of all of those individuals must make sense. And lastly, a quantitative variable can either be discrete with gaps between potential values or continuous with no gaps in between those values. All right, that's it for lecture 2. Deuces my gooses. I will see you next time.